So today, page 209, we're talking about the triangle mid-segment theorem. Okay, it's pretty easy. And again, every time you see the word theorem in math, it's just a fancy word for a rule, for a math rule. Okay, so mid-segment theorem. The word theorem is just a math rule. Okay, so here's what we know. So they're saying DE is a mid-segment. Okay, so if it's a mid-segment, here's what we know. We know a couple of things that are really important. If it's going to be a mid, like a midpoint, then I know that it cuts that side in half. It's a midpoint, right? So they go straight to the fact that, see the little dashes here? So I know AD is equal to DB, right? See the little dash that's saying these two sides are equal. That makes sense. It's a midpoint, right? Yeah. So it's got to happen. The same thing on the other side. You look at E, you see the double dash. So what they're trying to say is this side's equal to this side, which totally makes sense to me because if it's a mid-segment or midpoints in the middle, cuts it in half, right? But there's more. They also say that it's parallel. So we're going to say that DE is parallel to AC. And that's true of all mid-segments, that it will be parallel to its base. And we're also told that it's half the length of its base. That's the other thing. We saw that in our little introduction, okay? So, on this triangle, they didn't draw the others, but you could turn the paper around, right? And I could draw in another mid-segment right there. I'm guessing. Good point. But I'm eyeballing it, okay? I'm eyeballing it. Let's call this F. So I know that EF would be parallel to AB, right? EF would be parallel to AB. So I can say, okay, if it's a mid-segment, I'm going to say EF is parallel to AB. Okay? And I know that EF is 1/2 the length of AB, okay? Because it's a mid-segment, right? Now, since I drew F, there's another mid-segment, right? There's a mid-segment right here. Another mid-segment at DF. So I can say that DF is parallel to BC, right? And I know that DF is 1/2 as long, half the length as BC. So every triangle should have 3 mid-segments, right? 3 sides. Makes sense. 3 sides, 3 mid-segments. Okay? Parallel, half as long. Easy. Today's an easy day. You don't like today. Okay? So you ready to turn the page? Let's apply some out to what we know, okay? All right, so here we go. Easy, squeezy, lemon peasy. At least I hope so, huh? All right, let's take a look first at number 1, okay? Okay, so it is a mid-segment. We're told it's mid-segment. So if BC is 28, what's X? Half. Half. It's just 14. It's that easy. It is that easy, okay? Okay, now, number 2, if this is 15, this is half as long as X. How long is X? 30. It's that easy, okay? Number 3, if it is a mid-segment, then E is in the middle, which means if that's 9, that has to also be 9.
Wait, 9?
Sure, because if E is a midpoint, cuts it in half, 9 and 9. Easy day. You guys okay with this?
Yeah.
All right. Okay, let's do number 4. Let's go ahead and graph this one. -5 and 8. Is this even going to fit on there? I don't know. Let's see. Probably doesn't fit. I might use my own graph paper to do this one because it's kind of lame. They didn't give me enough graph. I'll just do this one on my own graph because I don't think I have enough graph paper there. Did you get it to fit?
8?
I bet I can get it to fit.
I bet if you go by 2s maybe, huh? I'm just going to do it this way, okay? A is 1, 2, 3, 4, 5, 6. Nope, 5. And then 1, 2, 3, 4, 5, 6. There's A. B is at 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, -4. There's C. Okay, well, it's going to fit on my graph. I don't think it fits on theirs, though. Does it? No. It doesn't. So you might have to go off your little grid. I'm not going to do that. I'm going to do a great job, okay? Okay. So the midsegments, let's find them. So the easiest way to find the midsegments is take a journey, right? Let's walk up from point to point and then go half the journey, right? That makes sense? So from A to B, I'd go up 1, 2, over 1, 2, 3, 4, 5, 6, 7, 8. Half that journey. Instead of 2, 8, how about 1, 4? 1, 1, 2, 3, 4. Okay, I'll call that X. That's a midpoint. Okay, let's go from B to C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And over 1, 2. Half the journey be 1, 2, 3, 4, 5, 6. And over 1. Let's call that Y. Again, I'm just finding midpoints by counting, right? It's pretty easy. Count and then take half the journey. From A to C is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And over 1, 2, 3, 4, 5, 6, 10, 6. How about 5, 4? 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay? Call that Z, okay? So the midsegments, just connect them, right? So I found the midpoints of all of these lines. And now I'm going to draw in my midsegments. There's a midsegment. And there's a midsegment. And there is a midsegment. Okay? Thumbs up? Yeah. It's not that bad, okay? Right. Everybody have that, or do you want me to wait a second?
Wait a second.
I can wait a second. So I drew my triangle. And I found the midpoints by just counting, right? And again, there is a formula for midpoint formula. You're going to find in geometry, we do everything visually because it's geometry class. But there is a midpoint formula. Anybody remember this one? X2 plus X1 over 2, comma. Remember this one? Do you remember the midpoint formula? No. Isn't it easier just to count? Right? And same thing with distance formula. Isn't it easier just to use the Pythagoras theorem? This is the way I teach geometry, visually. Algebra 2 is a little different. But geometry, I teach it visually, okay? Makes it easier, right? Okay, moving on. Okay, so let's take, now 5 looks kind of complicated, but I think I can do it. All right, so it says, what is the perimeter of DEF? So, okay, let me highlight that so I know what I'm looking for. So I'm looking for the perimeter of this, D, E, and F, okay? Yeah, there we go. Okay, so piece by piece, let me see. Now, you ready? Shh. This all the way across is 45, right?
Yes.
That's in the middle. How about 22.5? 22.5, right? E is in the middle, right? So 38. How about 19 and 19? You okay with that? D is a midpoint, right? So how about 6.5 and 6.5? Okay, thumbs up on that one? Okay. Now, if I want to find the length DE, okay? The length of DE is half of this segment here, which has to be 22.5. Right? If I want to find the length of EF, it's half of 13, right? Which makes it 6.5. If I want to find the length of DF, it's half of 38, which is 19. So my perimeter is going to be, let's see, 22.5 plus 6.5 plus 19. I'm just going to use my calculator. Somebody have a calculator handy? I got a calculator. Just do it real quick. All right, in my calculator, on, clear. 22.5 plus 6.5 plus 19. And I get an answer about 48, okay? Not too bad? All right. So, I've got, in number 6, am I going too fast?
No.
So I've got a mid-segment of the big triangle, and then I got a mid-segment of the little triangle. Okay? So if this is 52, what's half of 52?
26.
So 26. If If this is 26, so it's half of 26. That was easy. Can't even believe that was so easy. Bam. Done. Okay. All right. So, yeah, we can be done. We can be done. And stop.